Hello and very good morning, everyone. Welcome to Epsilon 2024. I am Shreyas Khernar, the publicity head at IEEE SISGST.
And I'm Adhruv, the technical head at IEEE SISGST. And we are delighted to be your host for the fourth iteration of our flagship event, Epsilon 2024, wherein our main goal is to provide an organized learning atmosphere and share technical information surrounding the theme Synergy of Realities, in which the CS track focuses on AR/VR and digital twins under the theme Reality Redefined. It will explore how augmented and virtual reality enhances the creation and utilization of digital twins. Attendees will learn about the integration of AR/VR with digital twins, work, advanced simulation, virtualization, and interaction in various industries, including manufacturing and healthcare.
Welcome, everyone. We believe that this session, an introduction to digital twinning, AR/VR, will offer you a lot of knowledge and expose you to many new ideas. And now, under the CS track, we have the first talk session of Epsilon 2024 entitled Simulation to Reality.
After the insightful session, there will be an interactive Q&A session where you can engage directly with the speaker, followed by the quiz. Now, let us begin with the most awaited session by welcoming our first guest for today. Now, let's welcome Mr. Jaikumar Goswami, sir.
Mr. Jaikumar Goswami is an MS graduate in robotics from Northeastern University, Boston. He has a rich background as a former junior research fellow at BVM and researcher at ISRO. With expertise in robotics, AR, VR, and digital twins and industrial automation, Mr. Goswami has built advanced robotic system and created a detailed digital twin for ISRO's thermo vacuum chamber. He has represented India internationally in robotic competitions, winning prestigious awards. His passion for robotics and space technology drives his continuous learning and exploration in the field. Welcome, sir. We're really thrilled to have you today, and we are really looking forward for this really incredible session.
Hello, sir.
Thank
How
you
are
so
you?
much. Hi, I'm doing well. How about you? I can see the comments. Okay, it's so
Yes,
nice.
sir. Everyone is
Oh,
excited.
yeah.
So, without any further ado, we'll like Mr. Goswami, sir, to kick off the session by shedding some light on digital twins as well as take our attendees through the broad realm of AR/VR. Now, over to you, sir.
Okay, sure. I think my screen is visible, right? Okay,
Yes, sir.
Yeah, it is visible.
perfect. Uh, so yeah, hey everyone. So before we jump into the world of digital twins and AR/VR, let me share a little about myself. Okay, but I promise it's not a boring resume readout or any kind of stuff. Okay, so first thing first, I'm a really good cook. Seriously, if this whole tech thing doesn't work out, you might just find me running a food truck here in Boston. Okay, so yeah, but for now, I'm pursuing my master's degree in robotics at Northeastern University. Along the way, I have had some exciting adventures and experience, like working with ISRO, where I helped implement digital twin technologies. And for the past year, I have been deep in the smart manufacturing industries as a researcher, exploring how robotics, digital twins, AR, VR can improve production lines. Okay, so yeah, today I'm thrilled to combine these experience and take you on a journey through the like intersection of digital twins and AR VR. Okay, so buckle up, get ready for some tech talks and maybe few cooking tips along the way. Okay, so yeah, going to the next slide. Introduction. So we are going to cover few things in this session. Okay, since it's your first session. Okay, so I'm going to cover the definition of digital twins. Okay, fundamentals of digital twins, like what is the definition of digital twin, what exactly it is. Okay, and benefits of it, few applications. Also, we'll talk about uh, a small confusion between one system and a digital twin. Okay, so let me tell you like one story. I was having one conversation with one of the professor here in Northeastern. Okay, so he said like, let's combine CPS, cyber physical system, with digital twin. Okay, I don't know if you guys have heard this term CPS, cyber physical system. Like you are from CS, so yes, probably you heard this term before. Okay, So like I didn't know, of course. So I just googled it and found out that CPS is a bridge between digital world and physical world. Okay, so like what's the difference between this? Like digital, it's the same, right? But it's not. It's same but different. Okay, so we are going to talk about that as well. Then we are going to see AR VR in digital twins. Okay, like how AR VR is improving our digital twins, specifically in visualization sectors. Okay, then we are going to see real world use cases and success stories. See now, like digital twin, it's not just a hypothetical thing right now. Okay, actual industries are using this concept, using these tools. Okay, for improving their production lines. So we are going to see a few stories of that as well. And then last but not the least, getting started with digital twin. Okay, so I'm gonna give you few steps that you should keep in mind while you develop digital twin with AR VR. Okay, it will be a general perspective, right? I think in the next session you are going to do some hands-on experience as well. So before that, it's good to know like the steps of making one digital twin. Okay, that you can like use it for your mini project or you can expand it later on. So yeah, this whole session is like a introductory session for digital twins and AR VR. Great. Okay. So yes, this is the session. Now let's move on to the next slide. But before that, you guys have joined this session. Okay. So obviously you are interested in digital twin and AR VR. Okay. Of course, apart from few people who are just here for attendance or something, because I did that stuff. But never mind. Okay. Uh, let's talk about what is digital twin. Okay, like have you googled it like before, or have you searched something regarding digital twin? I think this word itself is speaking. Okay, so can anyone tell me in the chat box quickly like what is digital twin, if you have any kind of idea? Let's see the chat. Okay, yes. Okay, you can tell. You can write like small definition of digital twin. Let's wait for 1 minute. Virtual replica. Okay. Yeah, technically it is. Yes. Okay. Virtual replica. Digital twin representation of a physical digital representation of physical object. Okay. Yes. Good answer. Yes. Perfect. Good. Okay. So at least you guys know what is digital twin is. Okay. So simply, uh, we can put we can put a digital twin. It's a digital replica of a virtual model of physical asset. It can be asset, it can be process, and it can be system. Okay, any kind of system. Okay, so it can be anything. Think of it like having a digital twin of something in real world that allows us to interact with and monitor and analyze it in virtual environment. For example, if I give you one quick demo, let's talk about this watch. Okay, so I have this watch physically with me. I have a digital twin of this watch. Okay, if I do something in virtual world, it will be reflected in the physical object as well. Okay, so like if I change the face of this watch, it will change the face on this physical object as well. Okay, this is a small demo. Digital twin can do a whole lot of things. We'll talk about that definition in a bit. Okay, so yeah, it's a general definition. Yes. So digital twin are not just the 3D model. They are living models. Okay. Like that are continuously feeding with real-time data from sensors, IoT device, and various other data points. Okay. So this makes them dynamic, constantly evolving. Dynamically constantly evolving. Okay, just like a physical entity they are representing. Cool. So now let's talk about the difference between CPS and digital twin. Okay, so let's clear up the confusion between these two. So both integrate digital and physical worlds, as I said. Okay, so, like CPS integrate digital world to physical world. It helps us in getting real-time data and also control. Okay, so like CPS focuses on real-time monitoring and control, like a thermostat controlling the temperature. Okay, behind me. Okay, but digital twin, on the other hand, take it further. They offer simulation, prediction, and deep analytics. Okay, by leveraging those real-time data. Okay, so they are like CPS on steroids. Okay, so you can use CPS, cyber physical system, for your digital twin model. Okay, CPS is really good for real-time data gathering and controlling. Okay, it can do a really good job of like for synchronization apart perspective. Okay, so you can use CPS for digital twins. Okay, so I hope this confusion is clear. Let's talk about benefits of digital twins. It's pretty obvious. Okay, like they offer several key benefits. The first one is enhanced decision making. By simulating various scenarios and analyzing outcomes, digital twins help in making informed decisions. Okay, predictive maintenance. They can predict when a machine might fail. Okay, or maybe like need maintenance. Okay, so this whole thing can reduce downtime and saving cost. Downtime is really important for any kind of industry, whether it's small or big. Okay, it can affect whole production line. So by predictive maintenance, it can reduce the downtime and also can save the cost. You can think of it as a crystal ball for industry equipment. Okay, it can predict. The last thing is improved product development. Before even making a physical prototype, you can test. You can test it. You can change it. Okay, and make a perfect product in its digital form. So this whole thing can speed up your development cycle. Okay, so yeah, uh like they are kind of limited, but these few advantages are really big uh, for any kind of industries. Okay, they can change the whole picture. Now let's talk about some applications of digital twin. Okay, I have one video. See, when I was doing research on digital twin, like when I was in ISRO, so I saw this video. It was the very first video I saw, like how digital twin works and what are the digital twins. I was blown away by this video. Let me tell you one fun fact is this video is 7 years old. Okay, and you are going to see how advanced it is. Okay, so like in the last decades, digital twins are like helping a lot in industries. So let me give you a brief overview about this video. So it is a video by General Electric Company. Okay, so they have made a digital twin of gas turbine. Okay, they have 15 years of data, 15 years of knowledge. Okay, imagine how good it is. This twin can predict whether it's needing maintenance, whether it's having some failure. Okay, or it can also predict financial outcomes. Like if we change this part, if we tweak something like this, then our production will improve by this percentage, and it will uh, improve, it will help, it will grow our companies by this percentage. Okay, and lastly they have integrated this whole thing, this whole digital twin, with a VR device. So why VR device? I think let me show you first and then we can see. Yeah. This whole video is like a 14 minutes long, but we are just going to see a main part. I highly recommend you to check this out. It's a really informative video. On rotor. Okay, listen the conversation between the twin and the operator. How twin answering the questions by using the previous data. I think it's like audible, right? Okay, let's check the video.
Okay, twin, help me understand the problem. What's your operating profile?
In past 6 months, my number of cold starts is 4, my number of warm starts is 8, my number of hot starts is 39. The number of start-stop cycles has increased by 27.5%.
Twin, tell me about your rotor damage.
My damage rate has increased by 4.0 times over last 6 months. If this continues, I would lose 69.9% of my useful life.
See, it's using past 6 months of data for predicting the failure. Okay, like if this continuously happening, then it will like lost 69.9% of remaining life. Okay, so it's using the previous data to predict the future.
Twin, give me options for mitigating that rotor damage.
Based on weather forecasts, historical data, fuel cost, electricity pricing and my present condition, I have two options for you to optimize operations. Option 1 is to manually slow down my startup ramp rate so that you can reduce the wear on my rotor.
Okay, so based on the like current weather state, the current like positions, cost, and also electric informations, and one more thing was that. So yeah, based on those data, it gives us two options. Okay, so first option can like reduce 10% stress, and the second option can reduce 25% of stress. Okay, it will tell you more. Just this in
Was to
just a
download
second.
the Opflex app and apply stress controls to minimize wear and reduce fuel consumption too.
Twin, give me the factors you use to calculate option 2.
I used my past 15 years of historical data, fleet learning from 125 other D11 steam turbines like me, and 58,965 simulation runs to get this recommendation. I'm 95% confident of my assumptions.
See, it's having 15 years of historical data. And not only that, okay, so they have 125, like 125 other digital twins as well. So this digital twin, this particular digital twin, it's also connected with those other twins. Okay, so it can see their data as well. Okay, and it ran like around 60,000 simulations. So based on the prediction, like based on the simulations, it gives us two options. How cool is that?
Twin, I need a financial perspective. Tell me about the numbers.
The numbers look good. We can reduce stress by 25%, which brings the damage rate back to normal range. Startup fuel cost will go down by 40% and startup time will be cut by 50%. You will also avoid $12 million by preventing an unplanned outage.
Twin, okay, I select option 2. Let's do it.
I'm initiating option 2, which is flex start. Thank you.
Okay, so it gives us two options, and also it applies that it applied the changes as well. Okay, so it's really cool. Now let me show you the VR part. So this device is called Microsoft HoloLens. Okay, it's quite old now. They have the upgraded version of this as well, which is called HoloLens 2. It's much more advanced than this, but yeah, it's of course obviously 7 years old video. So they have integrated that digital twin with this, so that they can see what's going on inside the turbine without going inside the turbine. Okay, it will make sense.
Is we
Just
would
a minute.
normally go into the actual physical plant and look at the steam turbine itself, the physical steam turbine. And from that physical steam turbine, what I would do there, let's make sure we get this to go right. What I would do there is I would overlay all of my digital capabilities on the physical asset, seeing exactly where the damage was occurring. Now, as I can't do that, I can't take us all on that journey. It's 6 hours away.
Yes.
What I'll do is I'll ask the twin to bring that to us, take the exact CAD dimensions of the asset from manufacturing and maintenance, and simulate it in this environment.
See, you can see that
Okay.
in action.
Twin, show me where the wear is.
Okay, it's showing where the damage is. See, exactly the spot.
Twin, show me the length of the wear and plot a baseline for me so I can see if we did.
See, it's also like measuring and predicting like how many years is still there. Okay, it's a really cool video. I think you should all watch this for like better understanding of digital twins. Okay, so this is specifically in manufacturing area, but I want you to focus in healthcare industries as well. Okay, so like healthcare industries, like I haven't explored it much yet, but it's a really cool industry. I think maybe some of you have interest in healthcare and this digital twins and AR/VR, so you can both combine these two. Okay, so Philips Healthcare developed a digital twin for like personalized treatment plans. Okay, so by simulating a human heart in a digital twin, doctor can test different approaches virtually before applying them to patients. Okay, so they have created a digital twin of human heart. So like doctor can see how hard like yeah, how your heart is working, whether you are having any kind of a heart disease, clotting, they can check your BP as well. Okay, everything. Let's see the video and like you can get more idea of from this.
Imagine a future where personalized healthcare will provide every individual the right type of care in the right way and at the right time. Imagine that every patient has a digital twin, a virtual representation of his health status. Let's explore how this could play a significant role when Mr. Clark, who has been diagnosed with atrial fibrillation, is seeing Dr. Sullivan, his cardiologist. Although AF is a highly prevalent disease, it can be complicated to decide on the individual treatment strategy for a patient like Mr. Clark. This is where his digital twin comes in. It starts by using Mr. Clark's medical data to create a patient-specific biophysical model, including a virtual version of his heart, which looks, behaves, and reacts just like the real one. Through a seamless flow of data and advanced analytics capabilities enabled by Philips Health Suite, Dr. Sullivan can connect Mr. Clark's digital twin with intelligence on similar cases and select ablation as the therapy with the best possible predicted outcome for him, both on.
Okay, so they have gathered the data. They made a digital twin of like a specific like for the patient's heart, and then they applied different methods. Okay, like which method is best suitable for this kind of a heart treatment. Okay, and they finalized the second one.
Short and on the long term. Dr. Sullivan carefully plans the procedure by simulating various ablation scenarios on Mr. Clark's digital twin. This enables her to select the one with the optimal computed result. The chosen ideal scenario forms the basis for real-time intervention guidance. During the procedure, all taken actions, as well as any unforeseen situations, are processed real time into Mr. Clark's digital twin to redirect if necessary. As a result, Mr. Clark received his treatment at the right time, in the right way, with the best possible outcome.
See, like in health industries, digital twins are just game changing. Okay, so yes, that's all about the application part. You can search more if you want to see, like you can search Siemens digital twin. Okay, so Siemens have made a digital twin of their wind farms. Okay, using AR/VR technologies as well. uh, they are using it for better optimizations and like for better efficiency management and all. Okay, so you can check that out as well. We are going to see a few success stories as well in just a few slides, but before that, now let's learn about AR/VR stuff. Okay, so like what are AR and VR? See, in this augmented like world and augmented technology, we have total four terms. First term is AR, second term is VR, third term is mixed reality, and the fourth one is XR, extended reality. Extended reality is an umbrella term, okay, which includes all these things. Okay, you can include AR, VR, and MR under the umbrella of XR. Okay, these three are main uh, terms in this world. We're not going to see the MR, but I'll explain what is a like MR. But before that, can anyone please tell me what is the difference between AR and VR? Quickly in the chat. Let's see what is AR and what is VR. Like basic difference between these two. Extended reality. Okay, anyone? AR gosh, interesting. Okay. Okay, no, okay. Let me just explain what is the difference between augmented reality and virtual reality. See, like AR overlays digital information onto the real world. I think you all guys have seen Pokemon Go game. Okay, so that was an AR game. You cannot interact with the object actually in AR. Okay, you can just see them. For example, if you have an iPhone or something, okay, if I want to see how iPhone 16 will look in my hand or onto my table, right? So I can just go to that website and install the AR application, and I can see how it will look, how the color is, like how the size of the button is, and like how slightly left camera will look. Okay, so yeah, but yes, you cannot interact with it, you cannot move, you cannot change the size, etc. So basically, AR overlays digital information onto the real world, right? So like imagine wearing a smart glasses that displays data right on top of what you are seeing. Okay, so that's AR. VR, on the other hand, immerse you in completely virtual world. Okay, it's like put on a VR headset and you are no longer here. You are in different digital created environment. The best example of it is metaverse. Okay, the whole meta thing is VR. You have your own avatar, you have your own world, you can interact with the object, you can create object, you can move, blah blah blah, you can do anything. Okay, so in VR you can interact with objects. In VR you can see the object in real world, but in MR you can do both the things. So it's a mixed reality. Okay, uh, you can create object, okay, and put it onto the like into the real world. You can scale it, you can throw the object into the wall and it will bounce back, all the physics law will apply onto that object. Okay, so you can interact basically, and you are in real world. So mixed reality is a combination of AR and VR. Cool. So I hope now you know what is AR and VR and different terms. We are not going to see MR right now. We are just focusing on AR and VR right now. Okay. So now that we have got the basic covered, let's see how AR and VR can elevate digital twins by adding more dimension to visualization and interactions. Okay, cool. So the role of AR, VR, and digital twins. So how does this fit with the digital twins? Well, AR and VR take this visualization of digital twins to the next level. With with AR, you can see real-time data and analytics right in front of you, overlaid onto the actual equipments or environment. Okay, as we just like saw in the G video, okay, the turbine one. So it's like turning data into visual stories. Okay, like imagine a factory worker looking at the machine and seeing a digital overlay showing its current status, okay, and also how it's performing, okay, and potential issues as well, all in real time. Okay, so we can use AR in this way. But the real magic happens with VR. Okay, like with VR, we can fully immerse ourselves in a digital twin environment. This is especially useful for training and simulation purposes. Like picture this: you are a new technician, and instead of like reading a boring manual, you put on a VR headset and walk through like a virtual model of equipments. Like you are going to work on, you can interact with it, you can take it apart, you can broke it, okay, you can put it back together, all without any risk. Talk about learning by doing. Okay, so yes, VR is really useful in this case. Also, doctor can use VR for like training a specific surgery. Okay, so they can like practice more that particular surgery. Okay, so these two are really cool uh, AR VR stuff in digital twins. Okay, so and these aren't just futuristic concept, this is happening right now. Companies like Boeing are using AR for aircraft assembling, okay, reducing errors and speeding up the whole process. In healthcare as well, as I said, like VR based digital twins are allowing surgeons to practice complex surgeries on like a virtual model of patients organs. Okay, so it's not just cool, it's game changing, right? So the combination of digital twins with AR and VR makes this digital replicas not just data points but experience. It allows for more intuitive decision making and better training, okay, and deeper understanding of complex systems. Okay, it's like having a superpower, like where you can see, interact, and manipulate both the digital and physical world seamlessly. How cool is this? Okay, cool. So I hope you know now like the role of AR, VR, and digital twin. Now let's see some use cases, okay, and successful stories. So like we have explored all the fundamentals and how AR, VR can supercharge digital twins. Now let's see some real world use cases. This example shows how companies and organizations are using digital twin combined with AR, VR to solve complex problems, okay, and enhance efficiencies. Specifically talking about in manufacturing, I have an example for like uh, digital twin with AR VR is a game changer. First thing first, Porsche use AR in combination with digital twins for real time quality assurance. Okay, so technicians uses AR glasses to visualize the digital twin of car components. Okay, so allowing them to spot any kind of a mismatch or defects instantaneously. Okay, so if they find any kind of a mismatch and defect, they can change that part immediately or like fix it immediately. This whole thing reduces errors, speed up the productions, and of course ensures higher quality control. Okay, this video itself is from Porsche. I have like a bunch of articles regarding this as well. If like if you guys want this, I'll just share those articles with the team, and maybe they can send it to you later on. Okay. So yes, talking about the healthcare sector, the impact is used, as I said, like for instance, Stanford Medical Center uses VR and digital twin for surgical planning and training. Okay, so surgeon can interact with 3D model of patient's anatomy, as I said before, for practice and practice. Okay, so they can practice complex procedures, okay, without any risk in virtual environment. This whole thing enhances like both the precision and also confidence of surgeon, so like ultimately improving patients outcomes. Okay, talking about in the energy sector, companies like Duke Energy employs digital twins with AR like uh, capabilities to monitor and optimize power grid operations. Field technician uses AR glasses as well, okay, to visualize ground assets and ease equipment's conditions. Okay, so they can see the equipment conditions, how it's performing, what is the health, and is it needing any kind of maintenance or etc. Okay, last but not the least, in autonomous industry, Volkswagen has implemented digital twins and VR in their car production process. Okay, they use VR-based digital twins. Uh, Designer and engineers can collaborate on vehicle development and testing. Okay, significantly reducing physical prototyping and cost. This whole thing can speed up uh, design cycle. This virtual environment also allows for rapid interactions and modifications. So like, which is a big win in the competitive automotive market. Okay, so yeah, I have also articles about this as well. We'll share it to the team, and they can send. Perfect. So let me tell you my experience with digital twin. Uh, See, this is the digital twin of a thermo vacuum chamber at ISRO. So, like at ISRO's Space Application Center, which is in Ahmedabad. So, we explored how digital twin technologies could enhance space engineering. Okay, specifically focusing on testing of payload in thermal and vacuum chamber. We called this thermovac chamber. Okay, so yeah, testing space hardwares like satellites and space probes and robots in simulated environment such as thermovac chamber is really crucial. Okay, this chamber mimics the extreme condition of space like high pressure and temperature. So like the traditional method of monitoring this tests involved manual tracking data. Okay, so like from multiple sensors to 2D screen, which was not only time consuming but also prone to errors and inefficiencies. Okay, so this was a real problem. Okay, so to address this problem, we developed an in-house digital twin of the thermovac chamber. This DT offers a real-time 3D visualization of thermovac chamber and its payload as well. I think you can see the payload. It's a quantum payload inside it. So they are testing it, and these are the real datas. If you look closely, all the datas are like quite near to 25 value, but these two are not. Okay, so it's giving us the garbage value, means TC26 and TC25 sensors are not working well. Okay, so we can conclude that. I'll show you the picture of this as well in a bit, but yeah. So yes, we developed a cross-platform app, including a mobile AR app and one for Microsoft HoloLens 2. We have the HoloLens 2, so we worked on that. As I said, it's really capable. that lets the user visualize real time data, and also can control digital twin with voice command. Okay, so we already prefit the few commands like twin, show the top view, twin, show the right view, and twin, go back to the home position. This is the home position, this is the left side view, and this is the top view of that. Okay, so by just giving the command, it can give the different view. Okay, so we used mostly Unity 3D for making the software. We used Blender for optimizing the model itself. Okay, and then we used a mixed reality toolkit, also known as MRDK, for data and interaction purposes. Okay, so these apps work on multi devices, desktop, mobile, or AR VR headset. Okay, we have published one research paper on this as well, and think I can show you that so you can have more idea. Let me just present that. Think share a window, and this and this. Think, yeah. Okay. See, this is the research paper. It's published in Current Science Journal. Application of digital twin in space energies. Okay, using augmented reality and Internet of Things. Let me tell you the model first. Yes. So this was the model. Okay. Uh, it was quite complex. Okay, we have unnecessary stuff here, pumps and all the nuts and bolts. So we optimize the model. Okay, because if we use this extra stuff, it will make the mesh file a whole lot bigger than we need. Okay, so we optimize this model using Blender, and then you can see the demos. Okay, so we have created a mobile application, AR application. You can just see. Okay, you cannot interact with this model actually. So what was our plan, like, was we want scientists to see how thermowave chamber looks, and like for like uh, where the sensor is and which sensor is giving which data. Okay, so scientists can install the app, they can connect with internal network of SAC. Okay, this is not available for outside the people, it's not on the internet, it's on SecNet. Okay, so at SEC we call SecNet. Okay, inside ISRO's network, so they can connect with the SecNet, and then they can see the real-time data. This is just a dummy version. This is the quantum payload testing inside the thermowave chamber, and this is of course desktop software and demo of Microsoft HoloLens. Okay, I'll show you a video in a bit. So yeah, this is the paper. I'll also give link to this paper if you want to read this. Let's go back to the presentation window, and here sharing. I hope everyone's like enjoying the session. Let me just see the chat. Interesting. Yes, 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 yes. Go I triple E. Okay. Okay. Nice. Yes, please. Okay. Definitely. Okay. So this is the quantum payload. Actually, specifically communication payload. This payload is right now orbiting our Earth. Okay, it's on board. Yes, this is the picture of testing of this particular quantum payload inside the thermowave chamber. And yeah, this is the video. It's in HoloLens 2. See, this is mixed reality. I can I can augment any kind of object onto the real world, and also I can interact with it. See, I'm scaling the object and I can move it. Okay, so this is called mixed reality. It's pretty cool, right? It's really close to like the Iron Man's hologram kind of a thing. Okay, yeah. And I'll just try to put this thermal chamber like onto my hand, on my hand like this. See, this is just me being me. Cool. Okay, so this is a demo of it. Okay, great. So now let me give you a few steps of how you can create your own digital twin with AR VR. Okay, so you can keep these things in your mind so that like it don't mess up. Okay, so yeah, all right. We have talked a lot about the what and why of digital twins and AR VR. Now let's get into how. How do you actually start implementing these technologies in your projects? Okay, spoiler alert, it's not about diving in head first, but rather taking a strategic steps, okay, step by step approach. Okay, so the first step is all about data. Digital twins are driven by data, so you need to collect and integrate data from various sources. Okay, uh, like from IoT sensors, machines, historical databases, you name it. Okay, but you have to have a data. For example, GE use 15 years of data and also uh, others digital twins data as well, right? So this is the foundation. Uh, Without accurate, high quality data, your digital twin is just a static model. Okay, so keep this in mind. You need data, you need data integration. Okay, next we move on to the creating digital models and simulations. So this is where tools like 3D modeling software come in, like Fusion 360, SolidWorks, Blender, Creo, etc. Okay, which like you can use anyone, uh, which you are comfortable in. Okay, so you need to create a digital replica that accurately mirrors the physical asset of system. Like think about Philips Healthcare, which like they developed a digital twin of human heart, right? So they used advanced modeling to replicate the heart's behavior, okay, allowing doctor to simulate and test different treatments. Okay, so it's really crucial to uh, create a 3D model, accurate 3D model of a physical asset, process or system, anything. Okay, so this is the second step. Now let's add a VR and AR layer to this mix. Augmented reality can provide real-time overlays of data onto physical objects. Okay, as we talked about this. While VR offers a fully immersed environment, right? So yes, the next step is analytics. This is where AI and machine learning algorithms comes in. Okay, like analyze the data for your digital twins. The insights generated, like uh, generated, can predict failures, optimize performance, and improve decision making. You can use MATLAB Simulink. Okay, you can use other digital twin platforms like Microsoft Azure Digital Twin. Okay, they are offering really good support for digital twins, specifically for digital twins. Okay, if you want to create your own algorithm and if you want to create your own machine learning model, you can use linear regressions and logistic regressions algorithms for like your own your own machine learning models. Okay, you can train the model based on the previous data or real time data, and based on that model it can predict failures, it can optimize performance, and it can improve decision making. Okay, cool. So to achieve all of this, you need the right tools and platforms. Popular platforms like Microsoft Azure Digital Twins, as I said, offers like comprehensive solutions for developing and managing digital twins. Okay, and let's not just forget about AR VR hardware. Okay, like Hololens and Oculus Quest. You can use any kind of Quest, but I prefer like Quest 3 is the best option. Quest 3 is a mixed reality headset. Okay, so it can augment, it can you can interact with the objects, and also you can create a VR world as well. Okay, I think it's a really good investment for any kind of organizations. Okay, if you are working in AR VR technologies and digital twins, so you should have this kind of tools. Okay, uh, it will help a lot. Okay, so this device can bring this digital experience to life. Selecting the right tool that align with your specific need is really critical. Okay, and of course there are challenges. Data security, integration complexity, and need for like specialized skills. Okay, are some hurdles. Okay, like they are terrible, and let me tell you, I am really weak in this area. Like I am improving myself for this kind of skills. Okay, so I really need to learn more about data security, because for any kind of industries, data security is a really big deal. Okay, it's no joke. They are really cautious about their data security. Okay, so yeah, but the key is to start small. Okay, start with a project like a digital twin of a single machine or a process, and then scale up. Okay, remember Volkswagen didn't started with a full blown VR based car production process. Okay, they started with a small projects, learned from them, and then expanded gradually. Okay, so it brings to the conclusion of this session. Okay, so like, all right, it's now done. Okay, so let's bring everything together. We have covered a lot of ground today about digital twins and how integrating AR VR can really take them to the next level. Okay, so the key takeaway here is that digital twins offer a dynamic, real-time, data-driven replicas of your physical asset. Okay, it can be asset, it can be process, it can be systems, any kind of systems. Okay, also adding AR VR into the mix enhance this digital twin by making them more interactive and immersive and accessible. Okay, so yes, whether it's for training, maintenance, or even a real-time operations. Okay, this integration opens up a whole new world of possibilities. We have seen practical examples today from like industries like manufacturing, healthcare, and energy. They aren't just hypothetical use cases. Okay, as I said before, companies are already seeing substantial benefits in terms of predictive maintenance. Okay, it can improve efficiency and it can improve decision making. Okay, but let's be clear. Okay, jumping into digital twins and AR VR isn't about rushing into big projects. Okay, keep this in mind. It requires thoughtful planning. Okay, proper data integration, selecting the right tools, and adapting an like interactive approach. Start small, learn from them, and then scale up strategically. Okay, so like, see, looking ahead, I can see like big potential for digital twins combined with AR VR is really huge. Let me tell you one thing. Here in US, recently they have passed one specific budget for cyber physical systems and digital twins. Okay, it's really recent. Like I guess it's in 2023. So they have a lot around $600,000 for small projects. So it's like 6 million Yes, for small projects, 10 millions for medium scale projects, and around 12 to 15 million dollars for a huge projects, okay, specifically in area of CPS and digital twins, right? So here in Northeastern, professors are looking for this, okay, professors are looking for students who know what is digital twin and who have some experience in digital twins and AR/VR. Okay, so you can start early. I guess you are whether you are in first year, second year, third year, fourth year. Okay, it's the best time to start. Okay, so like my final thoughts or a thought, it's just one thing. So thought. Okay, so my final thought for you is don't see this as just another tech trend. Okay, like think of it as a transformative tool that can drive both innovation and efficiency. Okay, again remember, start small, learn fast, and scale strategically. Okay, the future of digital twins and AR is really bright, and it is an exciting time to be a part of this digital evolution. Okay, keep this in mind, mark my words. Yes, thank you all for your time and attention. I hope this session has sparked some ideas and inspiration for how you can leverage digital twins and AR/VR in your own work. Okay, I'm happy to answer any kind of questions, and also you can connect with me on LinkedIn if you have uh, any other questions, and if you want to ask questions after this class or this sessions. Okay, you can feel free to DM me. I'll try to answer all of your questions. Okay.
Yes, sir. What a delightful session it was. Thank you so much, sir, for exposing us to the fascinating world of digital twinning and AR/VR.
Yeah, I hope everyone
So it was really
like
incredible.
this.
The chat was active throughout the
Okay,
yeah, yeah,
that's
yeah.
so nice.
Everyone
Thank you,
really
Chad.
enjoyed it. The chat was active. Moving
Yes,
ahead, now we'll
thank you so
start with the
much.
Q&A session. Therefore, if you have any questions or concern about the topic, feel free to post them in the chat box.
Okay, someone asked like what are some success stories and specific use cases of AR, VR, and digital twins. As we discussed this in slides, okay, like Porsche, BMW, Volkswagens are these companies are already using AR and VR based digital twins uh, for assembling purposes, okay, for designing and etc. So it's not the hypothetical thing. They are investing money, like big chunk of money for this kind of projects and all. Okay, so you can search that in Google, Porsche digital twin, BMW digital twin, and Volkswagen digital twin. You can see the articles. You can see how they are developing, how they are improving their production line by leveraging this AR VR based digital twins. Okay, what are some success stories? Okay, yeah. How can organization measure the ROI of teaching? Okay, that's an interesting question. So how can organization measures the ROI of implementing AR, VR, and digital twins? Okay, so return of investments. It's like a financial thing. Mm, see, I don't know about like how they are measuring this stuff, but see, maybe they can measure few things like AR/VR can decrease the training period. Okay, if they are using VR for training on new trainees, okay, so they can reduce the cost of actual machinery they are using. Also, they can decrease the time if they are using AR for maintenance and predictive stuff. Okay, combined with digital twin, they are decreasing the downtime. Okay, and for any kind of company, downtime is really important. If they are reducing the downtime, they are improving the production. Okay, and if they are improving production, their return of investments is really high. Okay, what data collected for how data collected for digital twins? Okay, how data collected for digital twins? Well, it depends. Okay, It can be like directly from Internet of Things. Okay, no, you can fetch the data from internet. uh, in ISRO's case, we were using internal networks. Okay, internal network is really fast compared to the internet thing, because we were using direct cables. Okay, because of safety purposes and all. But yeah, you can use any kind of cloud services like Amazon cloud service, Google cloud service, even Arduino has the IoT cloud service. Okay, so you can just send the data to cloud and then fetch it to your digital twin. Okay, so it's really cool. Future trends and developments in your digital twins. Okay, how can digital twins run astronaut training? Okay, this is a really good question. How can digital twin and AR/VR technology enhance ISRO space missions, especially in satellite design and astronaut training? Okay, see, uh, I don't have any idea for satellite design and astronaut training, but I can tell you they are using AR and VR for navigation. Okay, so the scientist I was working with, like, he was working on a project for visualizing the whole Ahmedabad city. Okay, so they can plan, they can manage the traffic, they can see where is the traffic is like really hectic and how they can improve that specific area. Okay, so the scientist wanted to like make a model of the whole city, and then they wanted to like visualize the whole city in VR itself. Okay, so yeah, this is a really good question. I think we can use digital twins and AR for satellite design and astronaut training. Definitely, I think some of them are also working in this area, but I don't know. Okay. Did you secure an internship in Russia and ISRO? Okay, sir, how did you secure your internship in Russia and ISRO? Okay, for this you can DM me. Okay, I'll tell you the process, like interview stuff and where to apply. Okay, you can DM me on LinkedIn and I'll share some stuff. Okay, in the same question.
So I guess that's all with the question answer part. Thank you so much, sir. We'd like to present with you with a small token of gratitude. We are really grateful to you, sir. Our participants surely learned something new and fascinating and insightful.
Yeah, thank you so much. Thank you so much, guys. Okay, thank you so much for your time. Thank you for inviting me. I would like to thank like Drusti. Like, she's really nice. She helped me a lot. Okay, Sanket, Shreyas, and Athav, of course, you. Thank you for inviting me, and thank you so much all the participants like for patiently listening to me. Okay. Uh, I hope you like the session. Okay. See you soon.
Yes, sir.
Best of luck for your future. Okay.
Yes,
Have
sir.
a
Really,
really
thank
good
you,
day.
sir. Yeah, yeah. I'm already planning a career in digital twinning, and I hope everyone is. The chat was totally active and was interactive throughout the session. So, with this, we'll conclude. We have posted the link for the quiz in the WhatsApp. Lastly, I would like to thank you for being an attentive audience. The skills you learned today will be used tomorrow in the hands-on session also. So, we hope to see you in
Yes.
the next session at 1:30 IST on the topic neurobytes. So, thank you once again and signing off.
Thank you so much. Have a good day.
Thank you, sir.
Thank you, sir.